Hello, in this video we are going to go over the solution of the problem 49, group anagrams. We are given a list of words like this one and we are going to group them in a way that all of the anagrams words are in one group. For example, here all of them are anagrams, here, and this one we have only one element for that. Okay, let's start writing the code. The first thing that we are going to do is to define a dictionary. Say D equals an empty dictionary. Also, I'm going to loop over all of the words in the string. So we say for word in strings. And I'm going to create a code for each word and record them as the keys of the dictionary. The code that I'm going to create is going to have 26 elements because we have 26 alphabet, and the assumption of this problem is that all of the words are small characters and alphabetical. So we say code equals, at the beginning I'm just gonna put the number 0 for all of the 26 codes. It's gonna be 26. Let me print the code. Say print code. Also, let me print the word. Say print word. Okay. And let me run this. So for example, for the first word, I have one code that all of them are right now 26.0. What I'm gonna do is going to go and, for example, I have A, so I'm gonna turn A to 1 because there is one A in this word, and E, say A, B, C, D, E. So this should turn to 1, and also the one for the T. Okay, let's see how can we do that. We come here and say for character in the word, for each character, now we are going to update the code and say code ORD of character minus the ORD of the first letter in our alphabet, which is A, plus equals 1. At the beginning it was 0. Now we are incrementing and making more. So this ORD is going to give you a unique code for each alphabet. And as we are going to only have 26, and this number here is not going to go over that, we are going to normalize that with the number of A. So in that case, the maximum value that we have here is going to be 26. Let me also print this updated code. Now see what happened. For example, for the word eat, for the first iteration for the character E, this code got updated. Then for the character A, this one got updated, and for the character T, this one got updated. Okay, so this is our final code for the word it. Now I can just put them in a dictionary that we defined at the beginning. I come out of the for loop and say if tuple code not in D. I need to convert the code to a tuple to be able to check that in the keys of the dictionary. If it is not part of the dictionary keys, I'm going to add that and say D tuple code equals word. Else D tuple code dot append word. Okay, if it is not part of that, we are going to start a list and put the word inside that, and if it is a part of that, we already have that unique code, so we are going to add that. So because that is another word with the exact same code, we are grouping them together. Okay, and at the end I just need to return the values of the dictionary we created. We say return d dot values. Okay, let's run it. And this is what we expected to see because now we grouped all of the anagrams together. Now let's talk about time and space complexities. For the time complexity, we have two for loops. The for loop that we have here is gonna be the order of n as the number of words in that list strs that we have. And also we have another for loop here that is going to go over the characters in each word, and where k is the maximum length of a word in the strs. And as the result, the time complexity is order of nk. The space complexity is also order of nk. We created this dictionary, and it's true that the dictionary keys are always need 26 spots. So that is not gonna be the main problem. The main problem is about the dictionary values, where we are recording all of the words. And we have n words, and that's the reason we have n. And also it matters how many characters we have in those words. For example, a word could have 2 or 3 characters, but another word could have much more. So because of that, we are going to also have this k. And as the result, the order of complexity is nk. Okay, this is the solution of the problem 49, and thank you so much again for watching this video.